So what I'm going to do now is I'm just going to go on and do a little bit about transistors. One of the questions that we do get asked from time to time is how a transistor works and how to use it to drive a device. So basically, a transistor is a switch. In the same way that if you consider water being electricity, in the same way that you can turn a tap on at home and water comes out, a transistor works like a tap. We can turn it on and off, and we can hold back a lot of water pressure and turn it with not very much effort. And a transistor is very much the same. It allows you, with a little bit of current, to drive a whole large amount of current. So that's what its purpose is in life. Now, there is two varieties of transistors, but I'm only going to really consider one here, which is the Npn transistor. And when we draw it on a circuit diagram, that's what an Npn transistor looks like. It's got three legs on it. The base is the input to the device, and then the collector is the output, and the emitter in an NPN, we tie that down to 0 volts. On the collector side, we then put a load here, so whatever we want to turn on. This could be a lamp, a motor, whatever it is that we want to drive, but something that takes a reasonable amount of power. There's no point in using a transistor if we don't need to have that power. What we then do, I'm just going to draw in a resistor here. What we want to do is make sure that we're not putting too much current into the base of the transistor, and a resistor there, something like a 10K, should do the job. So, how does the transistor work then? What happens if there's no volts on this pin here, so we've got 0 volts there, then no current is flowing down through the transistor. However, if we put at least 0.7, but we can put the full plus volts on here, so anything more than 0.7 volts on here, what happens is a small amount of current flows from the base through the emitter, and that switches the transistor on. And as that current flows, a much larger amount of current flows through the collector and down into the emitter of the transistor. And as that happens, this load, whatever that might be, a lamp, a motor, will turn on. So that's the basic operation. No volts, no current, nothing happens. Put at least 0.7 volts onto here, small amount of current flows through here, and a larger amount of current goes through the device. Now, there is something you probably don't need to worry about too much, but something called the gain. And we've got a maximum amount of current that can go through here. And that current, ICE, the collector emitter current, max, is going to be given by something called the gain and the input amount of current. So the amount of current that's flowing in through here, IBE, times the gain, gives us the total amount output. So a gain might typically be 100 times. So if we're putting in a milliamp in here, we can switch 100 amps through the device. So that's just something to be aware of. But most of the time you won't need to worry too much about what the gain of the transistor is. There's also a Pnp transistor. That one there was the Npn transistor. And with a Pnp transistor, it works in a similar way, but instead of connecting it down to ground, connecting it up to the power rail. So on the Pnp transistor, it sits there, and the load sits there. So that's a Pnp transistor. But other than that, it works in the same way. We need to make sure that the difference between here and here is greater than 0.7 volts. And when we do that, the current flows through the device. So that's how transistors work. There is a little bit more about a transistor, and I suppose it is worth just mentioning this. The transistor doesn't effectively turn straight on. There's a little bit of time when it's kind of not off, it's not on, it's kind of sort of a bit in between that. So if I was to draw a graph and we put 100% turned on up here, and 0% down here, what we'll find is that as we increase the voltage, it's completely turned off at the bottom here, and as that voltage increases, it then starts to turn on, and then it'll switch on to 100%, and this point here, that's the 0.7 volts that we're talking about. So it's not exactly 0.7, but it will switch on around there. So it doesn't go quite from being off to 1, but if we switch it from 0 volts to whatever the power rail is, it will switch on. So just to reiterate what the purpose of a transistor is, it's a device that allows a small amount of current to control a bigger amount of current. We've got the gain there that we need to worry about a little bit, and also there's two versions. There's an NPN and a Pnp, and then we have this curve that shows how it's turned on.